Hello student, welcome back to my channel Kunal sir at JEE NEET Chemistry World. So, in comparison with the last JEE Advanced discussions, there we discussed different scenario in terms of ionic equilibrium and solubility. Today's topic of discussion is another very important JEE Advanced model, which is nothing but a electrochemistry versus KSP mixing problem in galvanic cell. And this electrochemistry will come under the second year topic, and it is come under the physical chemistry. As far as JEE Advanced is concerned, based on the every year different IIT used to make a questions. Last year used to make Madras IIT. This year is going to make Kanpur IIT and sometimes Bombay IIT. So based on the different IITs, they used to make the questions, and the overall marks, it's not fixed. Sometimes paper is 60 marks, sometimes paper is 72 marks based on the situations. But the thing is minimum 17 to 18 questions on an average will be there. Multiple correct option will be there, column matching will be there, single correct will be there, all types of things will be there based on the 17 to 18 questions per paper per subject. So in chemistry, physical chemistry, sometimes weightage will be 40%, sometimes organic weightage is 45 to 50%. And out of that, if you observe, physical chemistry questions will be there, minimum 6 to 7 questions. Out of that, 1 questions definitely used to come from this region, electrochemistry. So that's why I choose this topic for the discussions. Now, straight away, we are going to that our topic of discussions. So if you look at, if they are giving like this galvanic cell AgNO3 1 slash AgNO3, why? This is solid and this will be aqueous. That means the salt will be dissolve in a particular solvent. And now this is a salt bridge, and here they will utilize soluble anion, insoluble salt or sparingly soluble salt, and with that metal. So this is another kind of electrode. Now if I write down these things properly, then we can write down Ag is converting to Ag plus. This Ag plus, from where it is coming? Silver nitrate is providing this Ag plus, this salt into the solution. And now this is a double dagger, which is nothing but a salt bridge. This is your salt bridge. This is your salt bridge. And this is Cl minus, soluble anion, sparingly soluble salt, and metal. This is acting as a cathode. Now you look at, in galvanic cell operations, always we need to write down, read like this, that Ag is converting to Ag plus by loss of electron. That means this half is a oxidation half. Oxidation half means that electrode act as a anode. Vowel for vowel, you can remember. And definitely this is, that means here which type of electrode they are utilizing as an anode? Metal and soluble salt of the metal, which can provide you the metal ion. Now here, rather than utilizing that metal ion is converting to the metal, they are using as a cathode another special type of electrode, which is nothing but a soluble anion. Cl minus is a soluble anion, AgCl is a sparingly soluble salt, and silver metal. So that is acting as a cathode, and this is your cathode. Cathode means the reduction hub. Now these both cathode and anode connected by a salt bridge. Salt bridge not only connecting the two half cell, but also complete the internal circuit, so that whenever outer circuit electron is flowing in a galvanic cell from anode to cathode, and current is used to flow from cathode to anode, opposite direction. So now that is why if you look at over here, in cathode there is a reduction reaction. And whenever this type of electrode, that means soluble anion, insoluble salt or sparingly soluble salt, and the metal acting as a particular electrode, it can be utilized as a cathode, it can be utilized as an anode. Cathode means, always you remember CG. Cathode means going, and anode means you remember AC. A means anode means coming, and in that particular, going means from middle, both the side going, coming means from both the side, it will come to the middle. So now that's why cathode means going means, you just remember my trick. From middle it will go to the both side. That means what reaction used to happen over here? In cathode means reduction. Reduction means gain of electron. And oxidation means loss of electron. So that's why in anode there is a no problem. What reactions will be taking place? In anode, Ag is converting to Ag plus by loss of 1 electrons. Ag is solid. Whenever ion will be there, that will be aqueous. Why? It will be surrounded by water molecules. And hydration energy, they will stabilize due to the hydration energy. Now this is an anode reaction. Then cathode, what reaction will happen? For that I give you the trick. What trick I gave you? My dear student, I trick you. Always remember, whenever this type of electrode they will utilize. When this electrode, that means soluble anion, insoluble salt or sparingly soluble salt, and the metal acting as electrode, then it can be utilized as a cathode. When they are utilizing as a cathode, then the written of that electrode will be there, soluble anion first, after that one slash, then sparingly soluble salt or insoluble salt, and then one slash, and then metal. So then that way they used to represent. And that time what you have to do, once or to write down the reactions, always remember cathode means Cg, going. That means from middle, both the side it is going. So that's why AgCl is converting to Ag and Cl minus by gain of electron. So then cathode reaction, one side you can write down AgCl taking 1 electron and converting to Ag and leaving behind the Cl minus. That means AgCl is a solid, Ag also solid, and Cl minus will be aqueous. And now if you look at very clearly, so now this is your anode reaction, loss of electron, cathode reaction, gain of electron, and salt bridge is connecting both the electrode. And now if you look at, this is that scenario is happening over there. Now based on that, JEE Advanced, how they will ask the model, that model now I am going to discuss. This is the basic fundamental idea of this type of electrode. Whenever this is acting as a anode, how they will write, you look at that time they will write like this, Ag, AgCl and soluble anion. This is that way when they will write, that means this electrode acting as a anode. An anode means, I told you, AC. AC means coming from both sides, it is coming middle. Cathode means Cg, going from middle, both side going. Anode means coming from both sides, it is coming to the middle. That means here how it will happen? Like this. Then immediately what I can write down, that means Ag is combining with a Cl minus, silver solid is combining with a Cl minus, which is aqueous, and then they are forming AgCl by loss of 1 electron. That means how it is happening? Silver is losing 1 electron, converting to Ag plus, and that Ag plus is combining with a Cl minus and forming AgCl solid. This is the funda. So now that's the way you will get like this. So that's why I told you my tricks, where you are never going to lose any idea. So now here situation is different, that is acting as a cathode. Let us look at JEE Advanced, how they will ask this model problem based on this type of galvanic electrode and KSP. Let us look at the next slide. So now here the problem, same thing I am giving, Ag plus, that means this metal and metal ion acting as a anode. From where metal ion is coming? From soluble salt of that particular metal. And now salt bridge, which is a double dagger. This is your salt bridge. Salt bridge, what is the role, my dear student? Salt bridge is nothing but a connecting the two half cell, oxidation half cell and reduction half cell. Not only connecting the two half cell, but also complete the internal circuit. So now galvanic cell is nothing but a very simple idea. Galvanic cell operation is nothing but a chemical energy will be converted to electrical energy. Galvanic cell is a device for the conversion of chemical energy to electrical energy. So now here what is going to happen? This Cl minus AgCl and this is your Ag. And I told you one sort how you will write down the reaction. Cathode means going. That means from middle it is going to this way. Now this is your cell, galvanic cell they are giving. So now as a anode, metal and metal ion, and as a cathode, soluble anion, insoluble salt and metal acting as a cathode. Now here what they are telling, here they are giving data E naught of Ag to Ag plus, this value they are giving minus 0.8 volt, and your KSP of AgCl, that is they provide you 10 power of minus 10, and then they are asking E naught of Cl minus AgCl Ag, this value will be equals to how much? That is a JEE Advanced very important model and standard JEE Advanced model. If you look at lot of standard book, even what are the material available, all top institute, if you look at like Akash, Allen, Narayana, Chaitanya, what are the standard national band institute, whatever material was there, their discussion is there based on that. But my dear student, it will not understandable easy to you. But if you look at my explanations will give you ultimate clarity, and you can solve this type of model problem very easily. Now here if you look at, in the anode also silver ion role is there, in cathode also silver ion role is there. It's like a concentration cell. So due to difference in concentration, there is a reaction is possible, then there is a flow of electron will be there from anode to cathode and cathode to anode. There will be a current flow when the galvanic cell operation will be there, discharging mode operation. Now the question is, it's like a concentration cell. It's like a concentration cell. That means same silver ion is present in anode, and silver ion also has a role in a cathode. It's like a concentration cell. So now what can I do? All those things, first we start these things. We know if I write down E naught cell, then what I can write down? E naught cell will be equals to E naught oxidation potential where at anode, plus E naught reduction potential where at cathode. I can write down these things. For this cell, if I write down E naught cell, what I can write down, my dear student? E naught cell will be equals to E naught oxidation. Who is undergoing oxidation? Ag is converting to Ag plus, that is acting as a anode. Previous slide, just now I explained all those points. Plus E naught reductions equals to soluble anion, sparingly soluble salt, and Ag is acting as a cathode. So then immediately E naught of Cl minus AgCl and Ag. Now here what is the way I need to remember? Ag is converting to Ag plus by loss of electron. And here how can I remember? This AgCl cathode means Cg going. AgCl is gaining 1 electron and converting to the Ag plus of AgCl is converting to the Ag, leaving behind the Cl minus into the cathode. Now this is your E naught cell. Then if I write down the next equation for these, what I can write down? Again I can write down one thing. You know very well, if oxidation potential is a negative, then reduction potential from same system will be what? Positive. Forward direction negative means backward direction positive. So even minus of oxidation potential is nothing but a reduction potential, positive reduction potential. So then from here what I can write down? From here I can write down E naught of Ag plus 2 Ag equals to how much will be there? 0.8 volt. I can write down. So that means oxidation potential negative means reduction potential from same system will be what? Positive. So that is the idea. So now if I know all those points, then I am coming how to solve this problem very easily and very elegant manner. So now we are writing E cell equals to E naught cell. Simply nonce equation I am writing. E cell will be equals to E naught cell minus 0.059. I can write down 0.06 by N. N is the number of moles of electron involved either in a oxidation process or in a reduction process. So then here N equals to 1. So that's why E cell will be equals to E naught cell minus 0.06 log of Q. Q is nothing but what? Reaction quotient. I hope you know everybody in chemical equilibrium chapter as well as ionic equilibrium chapter. is equilibrium chapter, you know these things very well. Reaction quotient is nothing but the expression wise reaction quotient and the equilibrium constant both are same, but concept wise Hevel and Leyland. Reaction quotient we can ask any time of the reaction, just reaction started also we can ask, but equilibrium constant only can be written when the rate of forward reactions will be equals to the rate of backward reaction. But expression wise both are same. Active mass or molar concentrations of the product raised to the power of the stoichiometric coefficient by active mass or molar concentrations of reactant raised to the power of the stoichiometric coefficient. In terms of a gases, partial pressure of the gases of the product raised to the power of the stoichiometric coefficient by partial pressure of gases of reactant raised to the power of the stoichiometric coefficient. But here there is in terms of a concentration is there, we will write down that things. So now this is the situation is coming into the picture. Now here if I write down the overall reaction, then overall reaction what is happening? Overall reaction if I write down, in anode what is happening? Anode happening, your anode what is reaction happening? Ag is converting to Ag plus, Ag means solid, and Ag plus by loss of one electron. Whenever you look at one slash is there means in between them there is a phase difference. So now anode this reaction happening, anode means oxidation, vowel for vowel, anode A vowel, oxidation O vowel. So that way you can remember very easily. So now, and this silver ion concentration means aqueous, where it is there? Anode. Then cathode what is happening? Cathode means is a reduction hub. Reduction means gain of electron. So you reduction what is happening? One shot you will write down the reaction. How? By looking my arrow. CG, cathode means going. So that's why AgCl is converting to Cl minus an Ag by gain of one electron. So then AgCl is a solid, it will be converted to your Ag and leaving behind the Cl minus, which is aqueous. Where it is there? It is at cathode. It is where? It is at cathode. Now this Ag plus at anode, Cl minus aqueous there in cathode, this Ag solid is there in cathode, this Ag solid is there in, this is in anode. This is the situation. Then overall reaction if I write down by adding this, if you add these two equations, then one electron cancel out. Then overall equation what is happening? This Ag solid anode, you look at, I am writing overall reactant. Ag solid where? This is at anode, and plus here AgCl solid which is there at cathode. AgCl solid where it is there? Cathode will be equals to then Ag plus aqueous where it is there? Ag plus aqueous where it is there? It is there at anode. Plus Ag solid where it is there? Ag solid, this is there at cathode. This is cathode. Plus if you look at plus Cl minus aqueous. This Cl minus aqueous. What it is there? This Cl minus aqueous is there in cathode. This is the scenario. Now, if you look at over here, this solid active mass is molar concentration or active mass we used to consider as a 1, because the solid is nothing but at a particular temperature and pressure, its active mass or molar concentration is nothing but the ratio of density and ratio of density and its ratio of molar mass. For a particular solid, their density at a particular temperature, their density and molar mass, that value is fixed. So that's why that ratio is a constant. For our convenience, we used to take as a unity. So that's why active mass or molar concentrations for the solid and liquid we used to consider as a 1. That's why I will not take into considerations of Q. Then overall reaction is this. Then my Q expressions, if I write down, Q expressions will be equals to silver ion concentration. Where? Because they are only at aqueous ion. So then silver ion concentration at anode, that anode means capital A I write down, and into chloride ion concentration where? At cathode, cathode means C. So this is your Q. Now this is your enhanced equation. E cell will be equals to E naught cell minus 0.059, which is nothing but a 0.06 by n. N is a number of moles of electron involved in an oxidation process or reduction process, which is nothing but a 1 mole of electron. That's why n equals to 1, and log Q equals to this expression, silver ion concentration at anode into chloride ion concentration at cathode. All other things are there. Solid active mass is nothing but a 1. Next slide, you look at next level of explanations. Then next level of explanations, we write down that your E cell equals to E naught cell minus 0.06 by this one 1, and log of Q equals to silver ion concentrations where at anode into chloride ion concentration where cathode. Now what I am taking, as there is a concentration difference was there, silver ion in anode and cathode, that's why reaction was feasible, and that's why this galvanic cell is working, as there is a concentration gradient is there. At equilibrium, concentration of silver ion in anode and concentration of silver ion cathode will be equal, then only E cell will be equals to 0. That means rate of forward direction reaction and rate of backward direction reactions will be equal. That's why E cell will be equals to what? 0. So now at equilibrium conditions I am taking. At equilibrium delta G equals to 0, as well as your E cell, that's why will be equals to 0. But delta G naught or E naught is based on the situation. It will be maybe 0 or may not be, not mandatory. But at equilibrium delta G 0, E cell always will be equals to 0 at equilibrium. Then if I apply that condition, another things will be there, and silver ion concentrations at anode will be equals to silver ion concentrations at cathode. That's why there will be no concentration gradient of silver ion is there. So as if the reactions will be like a standstill. So that's why that E cell will be equals to 0. That means the rate of conversion of silver to silver ion into the anode and again in cathode silver ion to the silver, both will be similar rate will be proceeding. So that's why silver ion concentration at anode will be equals to the silver ion concentration at cathode, because they reach the equilibrium, and at equilibrium E cell will be equals to 0, but E naught cell will not always will be equals to 0 at equilibrium. It may or may not be. So now here delta G 0, E cell is 0, then immediately what I can write down, E naught cell will be equals to 0. This part is 0. If you bring this side, this will be plus sign. So that's why 0.06 by this one log of silver ion concentration instead of anode, what I can write down, silver ion concentrations at cathode into chloride ion concentration at cathode. And now you know why at equilibrium there is a no concentration gradient. Silver ion concentration at anode will be equals to the silver ion concentration at cathode. And now you look at E naught cell equals to what we know, E naught of oxidation, means E naught of silver is converting to silver. This is a E naught of oxidation plus E naught of Cl minus AgCl and Ag. That means soluble anion, insoluble salt or sparingly soluble salt and metal acting as a cathode. So this is oxidation, this is a reduction, and these will be equals to 0.06 and log of, now you look at silver ion concentration and chloride ion concentration. Instead of that I can write down Ksp of AgCl. Previously we cannot. Why we took it? Now you understood why we took the equilibrium condition, because then only the silver ion concentration anode will be equals to the cathode silver ion concentration, then only silver ion cathode into chloride ion cathode concentration. Instead of that I can write down Ksp of AgCl. That's why I write down Ksp of AgCl. Now you look at these things will be equals to E naught of Cl minus AgCl and Ag will be equals to these things. If you take that side, then immediately this will be what? Minus of E naught of Ag to Ag plus 0.061 log of KSP of AgCl. They provided KSP of AgCl. KSP of AgCl they told. First slide we discussed. How much? 10 power of minus 10, my dear student. So then 10 power of minus 10. And now you look at minus of oxidation potential equals to, I can write down plus of reduction potential for particular metal ion system. So then immediately what I can write down? E naught of Cl minus AgCl Ag equals to, instead of these what I can write down? E naught of Ag plus 2 Ag. That means minus of oxidation potential equals to same system plus reduction potential. That's why Ag plus now is converting to Ag. That is a plus sign. So now plus of 0.06 by 1 log of 10 power of minus 10. Now this data already is there. You look at in our hand. E naught of Ag plus 2 Ag. It is they are giving in, this is nothing but a 0.8 volt. This data also they are in our hand. KSP also they are in our hand. Then this is only their question. They ask for this E naught value will be how much? From instead of these you will put 0.8 volt, and here log of 10 power of minus 10, base 10 is there. So then one equation, one unknown. From this equation you can do the simplifications and you can get the value of E naught of Cl minus AgCl Ag. So this is the very important model of JEE Advanced. To get this type of more model questions and get the success in upcoming JEE Advanced, come and have a look in my channel and comments to get a customized concept for your upcoming JEE Advanced. Thank you very much. Thank you all. See you in the next video, my dear student.